It's funny. They don't need right by professor, they need do I vibe it by professor. Alright guys, so 2-1 is huge. 2-1 is the section that takes algebra into calculus, right? So all calculus fundamentally does is it takes the idea of a slope that in algebra can only apply to a straight line, and it says, no, come on, we can apply that to a curvy dude if I just introduce this idea of limit. So the fundamentals of calculus is algebra plus the idea of limits, right? So this thing we're working on now, its main objective is to find the slope of a curve at a point, correct? If that curve is a line, I'm golden. It just never changes. I can find the slope anywhere I want to, and I'm done. Unfortunately for you guys, we're not going to be working with a lot of lines. So, all right. No, I'll do this right. No, I'll do it. I want to talk more about limits before I get into the which way do I want to do this? Yeah, I want to talk more about limits, and then we'll talk about the formal definition of slope in calculus. Then we'll see how far I can get. Let me ask you this. Can you guys figure out this here for me? So there's a lot behind what I hope most of you guys are doing right now. The idea of a limit is it's more straightforward than it seems. It just says, all right, if you can't plug the number in, simplify what it is. If you can, then plug the damn thing in. Yes? So a limit is trying to figure out what the value appears to be approaching. If I have a function that actually gets there, I just plug it in and see what it is. Does that make sense? So why would I say, what is an approach if I can actually just go there? If there's an open circle there, then I'm like, oh shit, I better get close to it. So, what is this? Do you have a lot of work to do? No. What do you do? That's crazy. So I get the square root of 9 minus 6 over 3 plus 2 times 3 is 3 minus 3 plus 6. So 3 minus 2, Jeff. That's good. Which is? 7. That's crazy. Okay. So a lot of what went into what we just did, there's a lot in there, believe it or not. There's something even more than what I'm about to talk about. Let me get your opinion of this. So this is, what should I call this? Sure. I'll call it the same the book does. Limit laws. Too many damn laws. We gotta limit them. No, I mean laws of limits. There we go. So, one law of limits is that if I have two functions, I can just take the limit of each one separately, which is kind of silly, yes? That's effectively what we just did, right? So if I have the limit of the sum of two functions, I can just add the limits of each function individually, which is effectively what we just did. And to be honest, what we really just did was the combination of this and, let me see if you guys are cool with this. This, is that okay? Plus or minus, plus or minus. Yes? Same thing. There is no subtraction, there's just adding the additive inverse. So it's,
There is no spoon.
so this is just fundamentally formalizing what you guys intuitively did up here. What about this business here? What the shit does this even mean, Jeff? Whenever you see a little c dude, that will almost always be a constant. Yes? So what do you think I can do? What would you actually, like, for example, when I had 2 times x, didn't you just sort of bypass the 2 and put the 3 into the x? Didn't you sort of take the 2 out of the way then? So this would just be this. Okay. I just want you guys to have the formalized limit laws somewhere. So if I have the limit of a constant multiple of a function, that's the constant multiple times the limit of the function. That's a really, really grandiose way of just going, just plug this number in, you know, so I can just multiply at the end. Oh, yeah. What do you guys think about this? First off, what does that mean? No.
Oh, F
Multiplication.
Multiplication. I like it. So what do you think the limit of f times g is? How can I rewrite that? The limit of
F of x.
f times the limit of g. Here, and just to give you there's one more of these, but just to give you a specific example of that last one. Does everybody have these down yet? What is this limit? Yeah, so you did the limit as x goes to 2 of x times the limit as x goes to 2 of square root of x minus 2, yes? Did you write that shit down? No. Did you think about it this way? No, but you did this. What's this? Holy shit. And what's this? 0. There you go. So we use these limit laws implicitly. We sort of, it just makes sense. The whole idea of a limit is, if you can plug the number in, do it. Because that'll tell you where the hell this thing is. It's all about figuring out where the function is. And what is the most fundamental way we figure out where a function is? We plug a number in. Where's the f at x equals 2? Plug the damn thing in. The limit says, if you can't do that, then I give you a way to simplify and then eventually plug it in. Yes? You guys kind of with me? So if I can do it, I do it. It's crazy. Okay. Oh, what's the one I left out? Oh, yeah. So the one I left out, number 4, you're never going to guess what this is. There's no way you can get it. There's no way. I'm being facetious. What? How do I rewrite that? The limit as x goes to a of f of x. What? Divided by the limit g of x. When does this not work?
When g of a equals
The limit as x goes to a of g of x is not 0. Have you guys ever seen that?
if and only if.
Good, if and only if. If I said, if it rains, I'll get my umbrella. But if I say, it rains if and only if I get my umbrella, that means it works both ways. Somehow I control the weather. If I get my umbrella, it'll rain. Put the umbrella down! Okay. So if you've never heard of if and only if, it just says the if then goes both ways. To be honest, it really should be easier, but I just wanted to introduce that. I think that's all of those. Oh yeah, good. Is that cool? These are nothing that are surprising, but again, I just want you to have the formal write-up of what these laws look like. Continuing down, what do you guys think about this? Anybody? Yes?
I have a question about 4.
Yes.
Why is it if it's not 0?
Oh yeah, I mean, if it is 0, then this has an issue, yes.
Right,
Then it's divided by 0, yeah?
right.
Okay.
So that means the bottom can't be 0.
Yeah, the bottom can't be 0, yes.
Okay.
So, what do you guys think about this? For example, what's the limit as x goes to 5 of x minus 2 cubed? What's that limit?
$27.
27, right? So what'd you do? You did
Plug it
the
in.
limit as x goes to 5 of x minus 2 all cubed. Yes? That's where you got 3, and then you cubed it. So you did the limit in that order, correct? You did 5 minus 2 first, which means you brought the limit in. So the general rule then is the limit of the nth power of f of x is equal to the nth power of the limit f of x. Now, when I use n, n, do you guys know what that means? Not integer. Natural number. It's crazy, right? Again, math people are very creative. Natural number, use n for natural number. Okay, so natural number, what the hell is a natural number? It's not supernatural, no. Cavemen. What came naturally to them in terms of numbers? 1, 2. Yes. Do you guys know that the number 0 had to be invented, and some civilizations never invented the idea of 0? Bless you. Some civilizations had the idea of 0, but they didn't have a symbol for it, which made it very confusing when they wanted 3,002 chairs, and they got 32 chairs, because they didn't have a symbol for 0. Yes? I don't think you guys are with me. Babylonians, they invented a symbol for 0, not too far before their civilization collapsed. So this guy's like, look, oh shit, we're dead. We had a good run, guys. That's the drunk history map. That's okay. So
it's whole numbers greater than 0.
yes, whole numbers greater than 0, or just positive integers. Yes. 6. So this is only if n is an element of the natural numbers. Maybe all math boyish. Meaning n is a positive integer. How does this work? Nth root. I'll just cut to the chase. It's the nth root of the limit. It's crazy. I'm still using n, so it still means the same requirement. What do you think about, all right, this is where we get silly. What do you think about this? This is kind of dumb. What's the limit as x goes to 47.3 of 11? What is the limit of 11 as x goes to 47.3? Does 11 give a shit what x is doing?
Yeah.
No. So it's 11. What does 11 do, right? As x gets really close to 11, don't care. Are you guys kind of with me? So what's the limit of a constant? It's the freaking constant, yes? So for example, the limit as x goes to negative 11 of 4. is 4. That's remarkable. Yes?
For 5 and 6, why can't n be negative?
It could lead to issues. For example, with n negative, it could lead to f of x can't be 0. Right? So we're just trying to be more, well, how do I say this? More general without getting too many restrictions. Yeah. But you're right. We can expand on these if we kind of introduce some more restrictions. Yes. Blah, 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 blah. Oh, what's this? All right, here, you guys, what's this? Holy shit. Yes. So as x goes to a, what does x do?
Goes to A.
Okay. Some of these are really dumb, but we'll make it through. Blah 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 blah. That's dumb. That's too dumb for me to even write. All right. Blah 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 blah. Okay, so we've already done section 2.3 for the most part, besides these incredibly awesome limit laws. So I've shown you several examples of what to do in certain situations. So can somebody figure out what we might need to do? What do you guys think about this? This is one we haven't really looked at directly, but what do you guys, oh, Jeff. Let me read this again. Go away. What's the very first thing you should do if this is a problem I give you? Plug in 0 and see if you're done, right? Are we done? No, why?
The whole thing's indeterminate.
That's more important. Bottom being 0 could be determinate because it could be some kind of infinity. It's 0 or 0, that sucks. Because that means I have work to do before I can figure out the answer. Okay, so what do you guys think I could do here? Very often the most direct thing is the thing to do.
Foil.
Yeah, foil. So what do you get when you foil that out on top? You get 9 plus h squared? Of course not. That's silly. You've got to write it twice, right? So you get 9 plus 3h, 6h plus h squared minus 9 over h. So, I mean, we've done these kind of problems before, and there's only so many types we can see. If I got a radical with shit, what do I think? Conjugate. If I get an indeterminate form, I think conjugate, right? If I get fractions and finite fractions, I think combined fractions so I can do stuff, yes? What else have we? Oh, if I get polynomials, I think factor, yes? This is the last type we hadn't talked about yet. If I just see stuff I can simplify, then I just directly simplify. What happens now?
9's cancel.
9's canceled. They were the only things that did not have an h, which is huge, because now I can take an h out of the top. Is that cool?
Yeah.
And the great thing there is,
We just cancel.
I can kill the problem, right? Again, not a life lesson. Okay. When anybody out there on the news, my math teacher said. Okay. So we could have made a table of values to investigate this, but why would we do that? You just get it algebraically. Well, and just to really hammer this home, what's the only time I can't divide h by h? If h is 0, and the great thing is the limit does not let it get to here. So in this case, it doesn't let it get to 0, so I'm allowed to kill it in this method. Some of you guys are going to wonder, did you have a student that killed equals? No, not yet. That I know. Yeah. We've seen that before. We talked about that already. Ooh, here's a new one. Okay. Here's a new one. Oh, what do you guys think about this? Let's do this one first. That one's really good. Any thoughts? You know, like,
Just show us how to do it.
thoughts. What's the issue with this? Why is 0 such a pivotal number here, besides it being the limit? Why have we taken the limitization as x goes to 0? What happens at 0 for the top function? That's the dividing line between where the absolute value actually does something, where it doesn't do anything. What's the absolute value of -3? The opposite of -3, correct? What's the absolute value of 3? Didn't do shit to it. So a quick little mini rant. I hate absolute value. It is the most evil thing, because it's not one function, it's two. I really want you to understand this. When does an absolute value actually do something? If the input's negative. So let's take a little side note. And this is very important. What is the absolute value of x if x is positive or 0?
X.
X. What does the absolute value do if I plug a 0 in or a positive number? It doesn't do shit. So the answer there is x. What is the absolute value of x if x is less than 0?
X times -1.
Negative x. Do y'all agree? Some students balk at that because you see the negative and you're like, it's not supposed to be a negative answer. And I'm like, it's not, because x is negative. So what's negative x? If x is negative, what's negative x? If x is negative, what's negative x? Positive. You guys with me? If x is -7, what's negative x? 7. So what's the absolute value of -7? -7, 7. So that's why I don't like absolute value. It hides the fact that it does two different things. It's not one function. In fact, what kind of function is this?
Piecewise.
Yes. This is, sorry, I can never, this is a pennywise function. They all float. No, this is a piecewise function. It's defined in pieces. Yes, but it's not very wise. I would argue with the second half of that. Are you guys all with me?
Yeah,
So if I'm, what is the limit as x goes to 0? What does that hide the fact? What does limit as x goes to 0 mean? What's it mean? What am I doing? What am I doing to do this? What am I doing? Nothing sneaky. What is the limit as x goes to 0? What's that mean? I'm letting x
Get closer to 0.
in what way?
Both.
From
Left and
the
right.
left and the right, yes? Okay. So what if I approach it from the right? How can I rewrite this if I'm using numbers that are above 0?
X over X.
Absolute value of x equals x. So what's x divided by x?
1.
Holy shit. If I approach it from the left, what's the absolute value of x?
X.
Negative x. What's negative x divided by x?
-1.
Does the limit exist?
Nope.
No. That limit does not exist. What's the absolute value of 3 divided by 3? 1. What's the absolute value of -3 divided by -3? -1. So it has two different values depending on which side of 0 it's on. That's why 0 is kind of like the knife's edge. Yes? Maybe. Screw jump. This is really important though. If you've never seen this before, then I apologize on behalf of my profession. This is something you should know. Absolute value of x is not one thing, it's two. It's x if their inputs are there, or it's negative x if the inputs are there. Which is why it's an evil little dude. So let me follow this up with this. What's the limit as x goes to 1 of the absolute value of x over x? Jeff, limit as x goes to 1 of the absolute value of x over x. There you go. 1. It never has, it's not around 0, is it? In fact, do I even give a shit about what this does around -1? No, I just care about 0.9, 0.99, yes, and bless you. So 0.9 divided by 0.9 is 1, 0.99 divided by 0.9, so you get 1. Is that okay? The only issue with the first one was I was dancing around 0, which is where everything changes. Okay, maybe. may go away. So here we go. Here's our first major theorem that's only going to show up a couple times. And this is the actual name of it. I can sometimes be goofy, and you guys are like, did you make that shit up? No, this is the actual name of this theorem. And this is such a cool idea. Okay. And I always am aware that if I say that, it might make you think less of it. I don't know. If you like it, I don't know. So here's the idea. If I have a function that is always between two other functions, yes? So for all x, or let me be more specific, for all x within some interval, okay? Let's make this all very specific. For all x in the interval a to b. You guys with me? So it could be from 3 to 7, this is true. So what does this just say on the surface? The outputs for f are always at least the output of g and at most the output of h. So it's always between those, yes? So like if g of 3 is 2 and h of 3 is 3, then f of 3 could be 2.5. Or it could be 2 or it could be 3. It's got to be between 2 and 3, yes? Is that cool?
Keep going.
Okay. So what if I want to know for something in A to B, let's say P. Yes, so here I have A to B, and P is just some number between, yes? And let's say at P, the limit as x goes to P of g of x is L, and the limit as x goes to P of h of x is L. So as I approach this point, this input P, the outputs for G go to L, and the outputs for H go to L. So visually, what does that look like? Here's my H function, here's my G function, and this is P. So let me see. This is my H function, it's the biggest dude. This is my G function, it's the smallest dude. But at P, they have the same limit. Is that cool? That limit is L here. Where is F in my picture?
L.
No. Where is F just generally?
Oh, in between.
Between A and B. It's got to be between H and G, correct? Eternally. So. Shit. Yes? So you can see why we call it the squeeze theorem. Do you know what the limit as x goes to P of of f of x? What's that gotta be?
L.
That's gotta be L. So if I have a function that is eternally, or like within a certain interval, is always between these two, and they agree at one point, or the limit at least is that. So maybe at that point they're undefined, but the limit is something that squeezes the middle function to have that same limit there. That sounds incredibly not useful. But let me show you the exact kind of problem this is useful for. So what if I had to figure out this? Oh, what you got, Jeff? I don't know. I'm not feeling creative. That one's kind of silly. Yeah, that'll work, sure. Well, the limit as x goes to 0 of x squared is 0, yes? And the limit of the sine thing is a little bit weird. Now, to be honest, you could actually figure this out, but it's okay. This is kind of a silly example, but we'll be okay. So watch this. Is there a part of this function I'm considering, is there a part of it that is bounded?
Sine.
Sine is bounded. You guys agree with me? What does that mean? It doesn't matter what's inside of sine, what can come out of sign? Only things that are between
1 and negative.
1 and negative. So that's bounded, yes? So, here's how these problems work. This is a silly example, but we're big. Take the part that is bounded and just write the fact. What is this always between? Like you just told me, -1 and 1, correct? Become a thing, there you go. You guys okay with that? I can write that shit down. If it was cosine, I could write the same shit down, yes? What's the middle piece missing to be the function I want? So let me multiply everything by x squared. Why is that legal? Because x squared is positive, so it's not going to freak out any of these inequalities. So I'm going to multiply everything by x squared. Do I have a function caught between two other functions? All day long. What's the limit as x goes to 0 of this function? That's 0. What's the limit as x goes to 0 of this function? Also 0. Therefore, what's the limit as x goes to 0 of this gotta be? Since it's caught between, it must be 0. So the limit of our function is at the same time greater than or equal to 0 as it is less than or equal to 0. So the only thing it could be 0. So it's all of its options have been squeezed away. Yes? Always think about the end of the first Terminator movie. Little hydraulic press. You got no options. Okay. Sorry. I live in references apparently, so. And most of my references go over everybody's head. That's okay. Is that all right? So squeeze theorem does not show up a lot. There's only a couple problems in the homework, I think. It will come up again later. It is really, really, really useful in one thing. Later. Right now it's just sort of a little like side note. It's really interesting, but okay. Okay. So now we get to the major part of today. Oh yeah, by the way, I am going to take us on a little field trip. So at around 1 or 1:05 or something around there. It's going to take like 10 minutes. Yes? And then you can go. So I don't want anybody to go too early. We'll be fine. We're going to make it. Okay. All right. This section is nifty. And I have no idea how that makes you feel. So let me remind us what this was. So the limit, if the limit as x goes to 5 of some function is 3. What happens, what does this mean happens then when my inputs get close to 5? What must happen for the statement to be true? If my inputs get really close to 5, what must happen? My outputs must get, if my inputs get really close to 5, my outputs must get really close to 3. Is everybody with me? Does that make sense? So in everything we've talked about limits, that's a nice kind of little quick way to summarize what it means. Yes? There's a really key word in there. Close. What the shit does close mean? Yes? Is 0.1 close to something? Sometimes not. There's a problem in the homework that deals with, you gotta get really stupid close to see what's going on because our function's doing this. So you gotta get really close to kind of like tune out all the noise. Yes? So what the shit? How do we define close? So this section is weird because the actual work you have to do feels like you're cheating. And it's a proof. We're gonna do some proofs. Yay, Jeff. Second day, and you're doing proofs. All right. So visually, as my inputs get close to 3, my outputs must get close to 5 in order for this statement to be, as my inputs get close to 5, my outputs must get close to 3 in order for this statement to be true, correct? So let's define close like this. A little this is the actual technical name for this. This is a little neighborhood around 5. And I'm going to say this neighborhood. Didn't I go up a little bit from 5 and down a little bit from 5? Yes? So I made a little interval around 5. So we call it a little neighborhood. Yes? Somebody back there close that door? Thanks, man. The distance I went out. You guys ready for this? We call it delta. So you know how you make a letter D? Well, to make a delta, you just do that. Delta is a little, it's a D that wants to be a musical note, I think. Oh, you guys are having none of that. Okay. It's just a letter. It's just a Greek little letter. Yes, or little letter. Delta means a very small distance on the x-axis. Is everybody with?
Is that
Yes.
uppercase or lowercase?
That's lowercase. Yeah. Uppercase delta is the delta you guys have seen. This guy. Like change in y over change in x. Some of your teachers show you that. This is the Greek letter delta. I think I have that right around. Now that I say it, I'm like, oh. One of those are 2 different cases of delta. So delta is the number that represents how far I go from 5. So here's the idea. If the limit really is 3, yes? Then that means however close someone wants me to get to 3, I can figure out a little neighborhood around 5 that will always get me that close. So, for example, my function could be doing this kind of thing. So if I use this, I'm always within this little box here. I got a better thing I'm going to show you that a computer can draw. My drawings leave just a bit to be desired. So as I get closer to 5, I can narrow the amount of room I need to get to be to 3. So if I was wrong, if the limit is actually 3, but I thought it was here, then very quickly, if somebody wants me to be this close, I am going to see that I'm wrong. I can't get that close. So the idea with this is, and let me define this. This distance here is epsilon. Oh shit. So this is the same idea. This is a neighborhood around 3 on the y-axis. And this one's controlled by delta, and this one's controlled by epsilon. All right, this is the day that everybody turns on me. So I really want this to make sense. If somebody comes along and says, oh, okay, yeah, if it's really 3, I want you to be within 1/10 of 3. So then I'm like, all right, well, if I go out this far, then I'm always within 1/10 of 3. So there. And then I'd be 1/100th away from 3. Then I just make this a little smaller, and then I'm always 1/100th away from 3. So if it's really the limit, I eventually have to be arbitrarily close to it forever. Okay, maybe. So let me show you, oh shit, I gotta find it, damn it. Let me show you. I mailed it to myself, so maybe I'll do that. Let's go to the everybody. Just hang out. No, I don't want that. Close. Oh, nothing's. My keyboard has decided to not work. There we go. Close ones. Everybody just hang out. Email. Me. All right, let's see. Woohoo! Oh crap! All right, y'all live this experience. Oh shit, you're a little busy, aren't you? Could I go back and text? Oh, I can email it to myself. It's a very interesting part of this.